Welcome to the Explainer. You know, if you've ever written a Python class just to hold some data, you know the feeling. You're writing the init method, the repref method, and you just end up with all this repetitive boilerplate code. Well, today we are digging into a fantastic feature that cleans all of that up: data classes.
Okay, here's how we're going to break it down. We'll start with that boilerplate problem I just mentioned, the thing that drives so many of us nuts. Then we'll get to the good part, the cleaner way using data classes and all the magic methods you get for free. After that, we'll dive into some advanced control and then wrap up by figuring out exactly when you should reach for this tool.
Right. So, as a Python developer, I'm almost certain you've done this. You just need a simple little container for some data, but you find yourself writing line after line of code that honestly adds more noise than it does clarity.
And this, right here, this says it all. On the left, you've got your standard class. You can just feel the pain of the boilerplate. The words rank and suit are repeated over and over and over again, just to get some really basic functionality. But on the right, oh, that is our destination. Clean, simple, and to the point. That's the before and after we're talking about.
So how do we make that jump? How do we go from all that clutter to something so clean and concise? The answer is just so beautifully simple. It's a decorator, one of Python's most powerful and elegant features.
A data class, at the end of the day, is just a regular Python class. But it's a class that's been supercharged. When you pop that @DataClass decorator right above your class definition, you're basically telling Python, hey, listen, this thing here, it's just for holding data. Could you do me a favor and handle all the boring, standard methods for me? And Python does it, no questions asked.
Okay, so what exactly does that decorator do behind the scenes? What are these so-called magic methods that you're getting completely for free?
Well, let's start with what you don't want. If you make an instance of our old regular card class and you try to print it, you get this, a memory address. I mean, what even is that? It tells you absolutely nothing about the card. Is it the ace of spades? The queen of hearts? Who knows? It's completely unhelpful. But with a data class, bam, you print an instance and you get this beautiful, clean, developer-friendly representation that tells you exactly what's inside. That is the power right there. Instant clarity with zero extra code from you.
So just to recap, by adding that one single line @DataClass, you automatically get a fully baked init method. You don't have to write it. You get that beautiful, readable endrep we just saw, and you get a sensible endQ method, which is huge for comparing objects. And believe it or not, there's even more, like ordering and hash.
And this is a really big deal. With a regular class, if you make two separate card objects, even with the exact same values, Python says they're not equal. Why? Because they're different objects living in different spots in memory. But a data class is smarter. It knows you want to compare what's inside. So now two Queen of Hearts cards are in fact equal. It just works the way you'd expect it to. But data classes aren't just for these simple, straightforward cases. They're also incredibly flexible. When you need a little more control, a bit more power over how your fields behave, Python gives you another awesome tool called fielding. Okay, now let's talk about a classic Python trap. Using mutable default arguments, like a list or a dictionary. Let's imagine we want to create a deck of cards, right? And if we don't give it any specific cards, we want it to default to a full 52-card deck. Well, the obvious way to do this leads to a really, really nasty bug. But here's the great part. Data classes are smart enough to save you from this headache. If you try that obvious but wrong approach, a data class will just stop you in your tracks. It raises a value error. It's preventing a bug where every single deck you create would accidentally share the exact same list of cards. Imagine shuffling one deck and having all of them change. It would be a disaster.
So, the solution, the crucial piece of the puzzle, is something called default factory. Here's the idea. Instead of giving it a pre-made value, you give it a function, a factory, that knows how to create that value. This function gets called every single time a new object is made, guaranteeing that each one gets its own brand new, unique default.
And this is what it looks like in your code. We define our cards field, but instead of equals some value, we use the field function. And inside we tell the default factory to use our function that makes a deck.
Now, every time you create a new deck, you get a fresh, full, unique set of 52 cards. Problem solved the right way.
All right, here's another common situation. What if you need to sort your cards? If you just set order equals true in the decorator, it's going to sort them alphabetically. That means ace would come before king, which, well, that's not how most card games work, is it?
The solution here is really quite clever. It's a three-step process. First, you set order equals true in the decorator. Second, you add a new field. Let's call it sort index, and you tell Python it's not part of the initializer. And third, you use a special method called post_init. This little guy runs right after the object has been created, and it's the perfect place for you to calculate your own custom sorting value based on your game's rules. The data class then uses that index for all its sorting.
So, with all this power and flexibility, you might be tempted to just use data classes for everything. But, being a great developer is about choosing the right tool for the job. So let's talk about when to reach for a data class and when something else, like a simple dictionary or a named tuple, might actually be better.
This table really lays it all out. If you just need simple, unstructured key-value pairs, hey, a dictionary is probably fine. It's low boilerplate and gets the job done. If you need something lightweight that's also immutable, meaning it can't be changed, a named tuple is a fantastic choice. But when you need a real, feature-rich object for your structured data with minimal boilerplate and total control, the data class is the undeniable champion.
The Hitchhiker's Guide to Python has this great term, ravioli code. You know what that is? It's when a project is just filled with hundreds of these little similar classes, all looking kind of the same, with no real structure. Data classes help you avoid that. They give you a clear, standard, and powerful way to define these data-holding objects and bring some sanity back to your code.
So really, the whole takeaway here is simple, but it's incredibly powerful. Data classes aren't just some new trick, they're a whole philosophy. They let you write less of the boring boilerplate stuff so you can focus on what actually matters, the meaningful, intention-driven parts of your code.
So, at the end of the day, remember that choosing the right structure isn't just about storing data. It's about communicating intent. It's about telling a clearer story with your code. Your data has a story. How are you going to tell it? Thanks for joining this explainer.